Hello, everybody. I hope you're having a great day. Hope it had a fantastic National Pancake Day if you were not here today. Um, I was planning on teaching 6.2 Part A during class today, but since we only had 3 people in second hour and 4 people in sixth hour, I decided to record this lesson. It should be about 10 minutes. So we are going to jump into this. 6.2, transforming random variables. That's what it's about. I'll move myself if it's covering anything. I don't think it is. But this should be familiar stuff for most of you guys. This is related to our concept of linear transformations on distributions of data. You guys should remember from chapter 2 that when we add or subtract a constant to a data distribution, that it adds or subtracts a to our measures of center and location, in this case mean expected value, but it does not change the shape or measure of our spread, which moving forward will be standard deviation. And when we multiply or divide, we multiply or divide by b. We do that to both of our center and location, and also to our measures of spread. But if we're doing it to our spread, so to our standard deviation, we're going to multiply or divide by the absolute value of b, so that we do not end up with a negative range or a negative standard deviation. That's not possible. So going into it, that concept that you guys learned about data distributions functions the same for these random variables that we apply them to. So if we are going to start by looking at multiplying random variables by a constant, multiplying a random variable by a constant, we are told that Pete offers some tourist day trips that allow up to 6 people, and it has to be more than 2 passengers. And we're defining X as the number of people that are selected to go or that are traveling on any given day. So you see our blue probability distribution table here. We have our X values, so since there has to be more than 2, we start with 2 and we count up by ones because we cannot divide people up into half people. And in that case, this makes X a discrete random variable. So the possible outcomes are having 2, 3, 4, 5, or 6 passengers. And listed below that are our probabilities for each of those outcomes. If we apply what we learned in section 6.1, we find that the mean or expected value of X is 3.75, and the standard deviation of X is 1.090. We find out we're told that Pete charges $150 per person. I would never pay $150 for anything, really. So I wouldn't be going on this trip, but apparently people do pay, and he makes quite a bit of money. So we're going to let C, a random variable C, describe the amount of money that Pete collects on a given day. And you'll see that since Pete can take 2, 3, 4, 5, or 6 people, that the corresponding columns in the orange or in the reddish table for C, the C1 is just 150 times X1. 2 people are going. He's charging $150 per person, so his revenue is $300. We do that all the way down. 3 times 150 is 450. 4 times 150 is 600. And so we finish going through our table and we see that these CIs are just 150 times any of our XIs. And that does have a purpose because we see that our mean is 562.50, which if you look on your calculator is exactly 150 times our mean of X, which was 3.75. That is no coincidence. You'll find out that the expected value of X times a constant is just that constant times the expected value of x. And our standard deviation has undergone the same change. If we multiplied 150 times 1.090, we would get 163.5, which is exactly what the standard deviation of C is. Now we'll see that the effect of multiplying or dividing, since they're inverse operations, it kind of functions the same way. If we multiply or divide our random variable by a constant b, this just multiplies or divides our measures of center and location, which in this case is expected value. We multiply or divide by b. We do exactly what we would expect we would do. Now for our measures of spread, which for this section will mostly focus on standard deviation. If we multiply or divide x by b, we are going to do the same thing, except we are going to multiply or divide the standard deviation of x by the absolute value of b. And this is because measures of spread have to be positive, they cannot be negative. They can be 0, but they cannot be negative, so we need to use the absolute value. You'll notice on this last slide that our distributions, the graphs on the right, maintain the same shape. They are just moved, being centered on around 3.75 to being centered around 562. So the shape is the same for the distributions. Now we're going to look at adding and subtracting. So we're using the same data. This orange table is the same exact thing that we used earlier. That's the revenue that Pete collects on any given day. It's repeated that the mean of C is 562.63.5. We're told that Pete pays $100 per trip as expenses to make sure that his trips go smoothly. So now we know how much Pete collects and we know how much Pete pays. So we want to describe or use the random variable v to describe the amount of money that Pete makes total, the profit that Pete makes. And so we're looking at the money that he collects minus the $100 that he pays per trip. And you can see, you'll notice that this bottom orange table, the VIs, V1 is exactly $100 less than C1. And so on for each one of these corresponding VIs and CIs. It's just CI minus 100 equals VI. So we have subtracted 100 from CI. And if we look at the mean of V using our standard, our expected value equation, we'll find that the mean of V is 462.5, and its standard deviation is 163.5. If you compare C is, the mean of C compared to the mean of V, it's exactly $100 less, which is what we have done. We've subtracted $100 from his revenue, so we can expect his profit to be $100 less. And you'll notice that the standard deviation has not changed. It has remained the same. And that is something that will happen for any time that we are adding or subtracting a constant. Our measure of spread, our standard deviation, will not change. So this is exactly what I was saying earlier, or I just said. If we are adding or subtracting a number a to any random variable, if we add or subtract a, we add or subtract a from the expected value. If we are adding standard deviation, adding or subtracting does not affect standard deviation, does not affect the spread or the shape of our distribution. So our standard deviation will be what it was before. It'll be, if we're doing x plus a, our standard deviation will still just be x. Now, linear transformations, if you have forgotten, a linear transformation is just any combination of adding, subtracting, multiplying, or dividing constants using a variable. So these two formulas at the bottom, the mean of y and the standard deviation of y, are useful, but they really in practical terms just mean that any combination of using the rules that we learned about adding, subtracting, multiplying, or dividing, we can combine those in any order that we like, and we can do it as many times as we want, and we will just follow the same rules. That is what those bottom equations are saying. These results apply to both discrete or continuous random variables, so you don't need to worry about discerning what kind of random variable or what kind of variable a random variable is when you're working with adding, subtracting, multiplying, or dividing constants. Finally, I made a little table with a lot of color in it, and this is just kind of a recap. It's a little diagram of what each thing does. So starting in red, if we add a constant a to x, so if we're looking at x plus a, the expected value of x plus a is equal to the expected value of x plus a. In the right column, you'll see that the standard deviation of x plus a is just the standard deviation of x. That's what we were saying, that adding or subtracting a constant to x does not change its standard deviation, and that is written in the bright green on the right hand side. Finally, secondly, in purple, if we are subtracting a constant a from x, the expected value of x minus a is just the expected value of x minus a. Subtracting or adding a constant does not change our standard deviation, so our standard deviation of x minus a is still standard deviation of x. If we are multiplying a constant b times our random variable x, the expected value of b times x is equal to b times the expected value of x. That's pretty straightforward. Our standard deviations here, now we can start changing them. Our standard deviation of b times x is equal to the absolute value of b times the standard deviation of x. This is different from adding and subtracting. It changes. And it changes by exactly what we'd expect it to. If we're multiplying by b, we just multiply our standard deviation by b, but we need to make sure that it's positive. So we use an absolute value. Finally, in blue, if we are dividing our random variable x by a constant b, the expected value of x divided by b is just the expected value of x divided by b. Standard deviation kind of functions the same way as when we're multiplying. We just follow, if we're dividing, we're going to do the standard deviation of x divided by b equals the standard deviation of x divided by the absolute value of b. Again, absolute value because standard deviation is never negative. That's written in turquoise on the right-hand side. Finally, at the very bottom, any combination of these operations, of these four basic math operations that you guys have known for a while, is considered a linear transformation of x. The slide before is telling us exactly that we can perform those two bottom equations. Basically what those mean in practical purposes for you, is that you guys can combine any of these operations as many times as you like, and as long as you're following the rules for them, you are okay to do so. So if we want to add something, if we want to add a constant to x, we're going to do x plus a, and if we're going to multiply it afterwards, we just do b of x plus a, and the expected values and standard deviations change accordingly. You'll notice that the second column, our expected value column, does exactly what we say in words it's doing. Our expecting by a, multiplying by b, or dividing by b. Our expected value does exactly what we would expect it to. We add, we multiply or divide our expected value by b. That's pretty normal. Our standard deviations do not change if we are adding or subtracting, just as a reminder. And if we're multiplying or dividing, we need to use absolute values. This is the end for today. just some side notes. We are going to keep on moving forward. Just because you guys were not here today does not mean that today was a day lost. So tomorrow we will be looking at combining random variables. I will be offering up some optional homework practice. I won't check it for a grade, but it's a very good practice for you for this section. And I will obviously be posting this video. Tomorrow we're going to do an activity about combining random variables. And by the end of tomorrow, you should be pretty confident doing both or all of section 6.2. Just a side note, on Thursday, we will have a quiz. This quiz was planned in using the days off or taking those into consideration. So do not complain to me about it, about not having enough time, because it was already like this. The snow day or the no bus driver day did not have an effect on when this quiz was going to be. So we'll have a quiz at the start of class. We'll have about half the class to go over any questions you guys have, but that's just going to be the schedule for the rest of the week, just so you guys know, so you're not panicking. And yes, so that is all I have for you guys today. I hope you guys enjoyed / are enjoying the sunshine. I am about to go play some soccer. But other than that, have a great night, and I hope to see you guys tomorrow.